Right now, as you listen to these words, your brain is doing something extraordinary. 86 billion neurons are firing in complex patterns, creating thoughts, memories, and awareness itself. But what if this activity isn't just electrical and chemical? What if the essence of consciousness reaches deeper into the strange, invisible world of quantum physics? Some scientists believe it might. They suggest that within your brain's microscopic structures, quantum processes could be shaping the very experience of being alive. The flicker of thought, the feeling of you. Others say that's impossible, insisting quantum effects can't last in something as warm and noisy as the human brain. Between these two views lies one of the greatest mysteries of science. Is consciousness a product of biology alone, or a window into the quantum nature of reality itself? In this chapter, we begin our journey, exploring what consciousness really is and why the answer might change how we see ourselves and the universe around us. Deep inside every neuron of your brain lies a hidden world, a microscopic architecture so intricate that some scientists believe it could hold the secret to consciousness itself. These structures are called microtubules, tiny cylindrical filaments that act like the scaffolding of your cells. They give shape to neurons, help transport molecules, and organize the chaos of your inner biology. But according to physicist Sir Roger Penrose and anesthesiologist Dr. Stuart Hameroff, microtubules might do much more than that. They could be functioning as quantum processors, carrying out calculations that go beyond classical computation, perhaps even giving rise to awareness. In their theory, known as orchestrated objective reduction, or OR, microtubules within neurons can enter delicate quantum states, where particles exist in multiple possibilities at once. When these quantum states collapse, they may generate moments of conscious experience, what you feel as thought, sensation, or emotion. If true, it would mean consciousness doesn't emerge from neurons firing in isolation, but from a synchronized quantum network that spans your entire brain. An orchestra of particles harmonizing in ways we're only beginning to imagine. Skeptics, of course, point out a serious problem. The brain is warm, wet, and noisy, the exact opposite of the controlled environment needed to sustain quantum effects. Quantum coherence, they argue, should vanish almost instantly in such biological conditions. Yet, emerging research in quantum biology, studies of photosynthesis, bird navigation, and even the sense of smell, suggest that quantum processes might in fact survive in living systems. If plants and animals can harness quantum effects, perhaps the human brain, shaped by millions of years of evolution, has learned to do the same. Microtubules may be more than scaffolding. They might be the stage upon which consciousness performs its mysterious play. And if that's true, it raises a profound question. Is your mind a product of matter? Or is matter expressing something deeper through your mind? Every thought you have, every decision, memory, and idea emerges from patterns of electrical activity in your brain. Billions of neurons exchange signals across tiny gaps called synapses, creating a living network more complex than any supercomputer ever built. But if the OR theory is even partly correct, your brain might not just be running on neurons, it could also be processing information in a way similar to a quantum computer. A classical computer uses bits, simple ones and zeros, to perform calculations. A quantum computer, however, uses qubits, units of information that can exist as 1, 0, or any combination of both at the same time, thanks to a principle called superposition. This allows quantum systems to explore many possibilities simultaneously, dramatically increasing their computational potential. Now, imagine if your thoughts worked like that, not in a rigid chain of cause and effect, but as vast webs of probability. Instead of single neurons firing in predictable patterns, perhaps your brain entertains multiple mental states at once, collapsing into a single outcome only when you become aware of it, much like a quantum measurement. Hameroff and Penrose propose that microtubules inside neurons might behave like qubits. When entangled, these structures could share information across the brain in ways that defy classical physics, forming a unified field of awareness. In simpler terms, consciousness might not be something your brain produces like a factory, but something it reveals, the way a radio tunes into invisible frequencies already present in the universe. Skeptics warn that this analogy may be too poetic. There's no direct evidence that quantum superposition or entanglement drives thought. Neuroscientists can explain a great deal about memory, decision-making, and perception without invoking quantum physics. Still, researchers are curious. Studies on photosynthetic organisms and migratory birds have shown that quantum effects can play roles in biological systems, even in warm conditions similar to the brain. And recent experiments have hinted that microtubules might resonate at frequencies compatible with quantum processes, suggesting that the idea may not be pure speculation after all. If consciousness involves quantum bits, even partially, it would mean your thoughts arise not only from neural chemistry, but also from the fundamental rules of reality itself. In that case, every idea, every dream, every act of creativity could be a small quantum event, a flicker of the universe becoming self-aware. Quantum states are notoriously fragile. Even a tiny disturbance, a fluctuation in temperature, a stray particle, or a ripple of noise can cause a quantum system to decohere, collapsing it into a single, classical state. This is why many scientists are skeptical about quantum consciousness. The human brain is warm, wet, and constantly buzzing with electrical activity. Hardly an environment you'd expect for delicate quantum effects to survive. Yet, some researchers believe the brain has special mechanisms to preserve quantum coherence, at least long enough to play a role in thought and awareness. One candidate is the microtubule, the tiny cylindrical structure inside neurons we discussed earlier. Microtubules may provide a protected space where quantum states can exist temporarily, shielded from the chaotic environment around them. Some theorists suggest that the protein lattice of microtubules could stabilize quantum vibrations, much like a crystal or superconducting circuit preserves coherence in a laboratory. Another possibility comes from the concept of quantum error correction. In artificial quantum computers, tiny errors caused by environmental noise are continuously corrected to maintain coherence. Could evolution have designed the brain to do something similar? It's a bold idea, but if true, it would mean your brain is not only capable of processing classical information, but actively protecting quantum information as well. Experimental evidence is still limited, but intriguing. Studies of quantum effects in biological systems, like photosynthetic molecules in plants and the magnetoreception of birds, show that life can harness quantum processes even at room temperature. These discoveries hint that biology might have evolved ways to preserve fragile quantum states, a necessary step if the brain truly operates as a quantum system. If microtubules or other structures can maintain coherence, even for microseconds, it might be enough to influence neural activity and create moments of conscious experience. In other words, your thoughts might be emerging not only from classical networks of neurons, but also from a fleeting quantum dance hidden deep within the brain. The implications are profound. If consciousness relies on quantum coherence, it's not just a byproduct of matter. It becomes a bridge between the microscopic world of particles and the macroscopic world of minds. A reminder that the laws of physics could reach directly into the experience of being alive. Consciousness might not be confined to a single brain. Some scientists speculate that the principles of quantum mechanics could extend to networks of minds, influencing how we interact, cooperate, and even experience empathy. In quantum systems, particles can become entangled, sharing information instantaneously over distances. Actions on one particle can affect another, no matter how far apart they are. This mysterious connection has led researchers to wonder, could similar principles play a role in how human minds interact? Consider altruism, the act of putting others' needs above your own. Evolutionary biologists have long studied it, suggesting it arises from social structures, genetics, and reciprocal benefits. But what if there's another layer? A subtle underlying connection between conscious agents that enhances cooperation. Some theorists suggest that quantum processes in the brain could make empathy and intuition more than just psychological phenomena. If microtubules or other quantum structures influence thought, and if these processes can interact at a subtle, non-local level, then the bonds between individuals could be influenced by the same fundamental physics that governs particles. Experiments in quantum biology and entanglement hint that systems can share information in ways classical physics cannot fully explain. While it's far from proven in humans, the idea sparks fascinating possibilities. Minds might be connected in ways that science has only begun to explore, providing a potential physical basis for intuition, empathy, and shared consciousness. Even without invoking direct quantum connections between brains, understanding quantum principles changes how we think about cooperation and awareness. Life itself may have evolved to exploit subtle quantum effects, and these effects could shape the ways we act, care for others, and perceive the world. In this light, altruism may not just be a social strategy, it could be part of the quantum architecture of consciousness itself. The universe, it seems, might have built empathy into our very being, linking minds together in a web far more intricate than any neuron network. Life is a master engineer. Over billions of years, evolution has refined the structures of cells, brains, and organisms to survive in a complex, ever-changing world. But some scientists ask a provocative question. Could evolution have gone even further, designing the brain to support quantum processes? The argument begins with the observation that microtubules are highly conserved structures found in almost every cell of complex organisms. Their remarkable stability and intricate geometry suggest they aren't just incidental scaffolding. Some researchers propose that evolution may have optimized microtubules to protect quantum coherence, allowing fleeting quantum states to influence neural activity. Consider the challenges. Quantum states are fragile, easily destroyed by heat, vibration, and noise. For a quantum mind to function, evolution would need to create structures capable of shielding these delicate states. Proteins, water layers, and cytoskeletal networks might all play a role, providing a natural architecture for quantum computation in the warm, wet environment of the brain. This idea doesn't claim the brain is a perfect quantum computer, but it opens the possibility that evolution could have favored organisms whose neural architecture allowed enhanced information processing, creativity, and awareness. Consciousness in this view might not just be a byproduct of biology. It could be an emergent feature shaped by millions of years of natural selection. Supporters of this perspective also point out that certain behaviors, problem-solving, abstract reasoning, and rapid decision-making, often outpace what classical neuron-based computation alone seems capable of producing. Could quantum effects give a subtle edge to cognition, helping organisms survive and thrive? Of course, skeptics caution that these ideas remain speculative, proving that evolution specifically selected for quantum capabilities is challenging. Yet, even as a hypothesis, it offers a fascinating lens through which to view consciousness, not as a random accident of biology, but potentially as a carefully tuned product of evolution, optimized for awareness, learning, and perhaps even creativity. If true, every thought you have, every insight, every spark of imagination might carry the imprint of both quantum physics and millions of years of evolutionary design. Consciousness is the most intimate and mysterious aspect of being alive. It is the moment you become aware of a thought, feel an emotion, or notice the world around you. But where does this spark actually come from? If the theories we've discussed hold any truth, consciousness may arise not just from the electrical activity of neurons, but from quantum processes occurring deep within the brain's microtubules. These microscopic structures could generate fleeting quantum states, orchestrating them in ways that ultimately give rise to awareness. Some scientists describe this process as the brain's quantum orchestration, a delicate synchronization of quantum events that collapse into moments of conscious experience. Each thought, sensation, or decision could be a small, coherent quantum event manifesting at the level of perception. Yet consciousness isn't just about physics. It also emerges from the interplay of millions of neurons, their networks firing in complex patterns honed by evolution. The brain may combine classical and quantum computation seamlessly, producing a unified experience that feels effortless, immediate, and rich with meaning. Consider for a moment the sensation of seeing a sunset or hearing a piece of music. These experiences are more than chemical reactions in your brain. They carry a quality, a presence, a vividness that classical computation alone struggles to explain. Could it be that the quantum architecture of the brain contributes to this richness? The subtle nuances that make consciousness so deeply subjective? The spark of consciousness, then, may be the point where biology, physics, and experience converge. It is where evolution's design, neural networks, and quantum possibilities meet, giving rise to the you that observes, feels, and thinks. While science has yet to fully unravel this mystery, exploring these ideas opens a new perspective. Consciousness may not simply be something the brain produces, but something the brain allows to emerge, a subtle dance between the laws of physics and the complexity of life itself. Every day, millions of people undergo surgery under anesthesia. Drugs like propofol or ketamine temporarily switch off consciousness, leaving the body alive while the mind seemingly disappears. But what does this reveal about the nature of awareness itself? Traditional neuroscience explains anesthesia as a suppression of neural activity, a chemical interruption of signaling between neurons. But the quantum consciousness hypothesis suggests something deeper. Anesthetics may not simply block classical electrical signals. They could disrupt the delicate quantum processes within microtubules, effectively silencing the orchestrated quantum states that contribute to consciousness. Experiments show that anesthetic molecules bind to specific proteins, including tubulin, the main component of microtubules. By altering their vibrations, these molecules could interfere with quantum coherence, the very mechanism proposed to generate conscious experience. In this view, anesthesia isn't just slowing the brain down, it's temporarily turning off the quantum spark that produces awareness. This idea provides a fascinating perspective on the fragility and precision of consciousness. If awareness depends on quantum states, even subtle molecular changes could shift or extinguish it. It also suggests that the mind is more than a byproduct of neuron firing. It may be an emergent phenomenon arising from both classical and quantum mechanisms. Understanding how anesthetics affect consciousness could have profound implications. It might help explain why some experiences, like dreams or near-death sensations, persist even when classical brain activity is reduced. And it could illuminate the conditions necessary for consciousness to arise, deepening our understanding of what it truly means to be aware. In essence, anesthesia offers a rare window into the quantum mind, a glimpse at the mechanisms that flicker to life when we are awake and fade when consciousness is suspended. As we explore consciousness in the brain, a natural question arises. Can we recreate it artificially? Modern computers simulate neural networks, but they operate on classical bits, simple ones and zeros. Could building machines that harness quantum computing principles bring us closer to creating something resembling consciousness? Researchers in quantum computing and artificial intelligence are beginning to explore this frontier. Quantum computers process information using qubits, which can exist in multiple states simultaneously. This allows them to evaluate many possibilities at once, a property that, in theory, could mimic aspects of the brain's quantum processing. Some theorists suggest that by designing artificial quantum networks, we might uncover principles of consciousness that remain hidden in biological systems. If microtubules and quantum coherence are essential to awareness, building machines that replicate these features could teach us not just how consciousness works, but why it arises. The implications are both exciting and controversial. Could a quantum machine develop self-awareness? Could it experience subjective perception? While we are far from answering these questions, experiments in quantum-inspired AI reveal surprising emergent behaviors, patterns that hint at more than just programmed responses. Exploring artificial quantum consciousness also forces us to confront philosophical questions. If a machine achieves awareness, how would we recognize it? What ethical responsibilities would we have toward an entity that perceives, even in ways different from humans? By studying consciousness in artificial systems, we gain a mirror for understanding our own minds. These efforts may reveal that awareness is not a mystical property, but a natural outcome of complex quantum networks, whether in neurons or engineered qubits. In the search for artificial quantum consciousness, we are learning as much about ourselves as we are about machines, uncovering the fundamental principles that might make the universe aware of itself. Quantum states are fragile. In artificial quantum computers, even tiny disturbances can destroy information, so engineers use quantum error correction to protect and stabilize these delicate states. But what about the brain? Could evolution have developed similar strategies to preserve quantum processes necessary for consciousness? Some theorists suggest that microtubules and other cellular structures may act as biological error-correcting systems. These structures could help maintain coherence despite the brain's warm, noisy environment, shielding fleeting quantum states long enough to influence neural activity. The idea is speculative, but intriguing. In quantum computing, error correction involves redundancies, entanglement, and carefully designed circuits. Nature might have evolved analogous mechanisms at the molecular level. Proteins, water layers, and cytoskeletal arrangements could all play roles in protecting quantum states, ensuring that the orchestration required for consciousness remains intact. If evolution indeed optimized the brain for quantum error correction, it suggests that consciousness is not an accidental byproduct of biology. Instead, it may be a feature finely tuned by natural selection, designed to maintain fragile quantum information long enough to produce awareness, creativity, and flexible thinking. This perspective also reframes our understanding of mental resilience. Disruptions to these delicate quantum systems could contribute to disorders of perception, memory, or cognition, offering a new lens for studying mental health at the quantum level. In essence, if the brain uses natural quantum error correction, consciousness is more than a fleeting phenomenon. It becomes a robust, emergent property, delicately balanced between chaos and coherence, biology and quantum physics. A system evolution has refined over millions of years. If consciousness relies on delicate quantum processes, it's natural to wonder how disruptions in these systems might affect the mind. Could mental health disorders, in part, reflect imbalances in the brain's quantum activity? While classical neuroscience explains much about psychiatric conditions, neurotransmitter imbalances, neural circuitry, and genetics, the quantum perspective offers a complementary lens. If microtubules and other cellular structures support quantum coherence, then disturbances at this level could subtly influence cognition, mood, and perception. For example, conditions such as depression, anxiety, or schizophrenia involve altered patterns of thought and perception. If quantum processes play a role in synchronizing neural networks, disruptions could contribute to the subjective experiences of these conditions. Understanding this may inspire novel approaches to treatment, targeting the underlying physical mechanisms in ways classical models cannot fully address. Quantum psychiatry is still largely theoretical, but early research points to intriguing possibilities. Studying how microtubules respond to chemical or physical changes, or how quantum coherence fluctuates in living brains, could reveal hidden layers of mental function. Even if these effects are subtle, they may help explain phenomena like creativity, intuition, or sudden insights, aspects of the mind that classical neuroscience struggles to quantify. Ultimately, exploring consciousness through the lens of quantum physics doesn't just expand our understanding of thought, it opens a new frontier for mental health. By investigating the fundamental mechanisms underlying awareness, we may develop a deeper understanding of why minds sometimes falter and how to help them flourish. As we reach the final chapter of our journey, one question remains. If consciousness is influenced by quantum processes, could we one day enhance the quantum mind? Could understanding these principles allow humans to expand awareness, creativity, or cognitive abilities beyond what evolution has provided? Some scientists imagine a future where we learn to support or optimize quantum coherence in the brain through advanced technology, pharmaceuticals, or training techniques. Microtubules, neural networks, and even artificial quantum systems could be tuned to amplify thought, intuition, and perception. The implications are profound. If consciousness is a quantum phenomenon, then enhancing it could unlock new ways of experiencing the world, connecting with others, and understanding reality itself. Art, science, and philosophy might all benefit from a deeper integration of mind and the fundamental fabric of the universe. Yet this frontier is not without caution. Interfering with quantum processes in the brain carries unknown risks. Consciousness is fragile, a delicate balance of biology and physics. Enhancing it artificially could have unintended consequences for identity, perception, and mental well-being. Still, the pursuit is inspiring. By exploring the quantum nature of the mind, we are not only seeking knowledge, we are exploring what it truly means to be aware, to think, and to experience. Each discovery brings us closer to understanding the mysterious connection between matter, energy, and the self. Perhaps one day, humanity will not only comprehend consciousness but also participate consciously in the quantum universe. A universe in which every thought, every insight, and every choice is a reflection of the fundamental processes that shape reality itself. And in that possibility lies the ultimate wonder. The mind, in all its complexity, may be both a product of the universe and a window through which the universe becomes aware of itself.